Hey kids, so here is our second follow-up lesson to position, velocity, and acceleration. So this is just me going through another handout of what type of problem that AP might ask you about PVA. So I want you to notice firstly that I'm giving you a position function. You can see the variable S there. But you can also notice the units, right? Position is with respect to time. Time is measured in seconds. Height is measured in meters. Also notice the algebra oneness of this position equation, right? It's a parabola that opens upside down. Also, I can tell, and you'll start to get used to this as well, I can tell that even if they hadn't said I was measuring in meters, because the coefficient isn't -16, right? Remember, this is 1/2 GT squared here. So it's half of 9.8, which is the effect due to gravity in meters per second. So find Wile E. Coyote's velocity in terms of t, that means when it says in terms of, that means I need an equation instead of finding the velocity at time 2. Right? In terms of t just means I need the equation, and you're expected to know that with a position equation, velocity is the first derivative of position. You don't have to write S prime. It's just good to write a habit to get into, so you keep remembering that the first position is velocity. Derivative of the first position is velocity. So taking the derivative here, I get 24 minus my 9.8 t. Velocity is linear because position was quadratic. Find Wile's acceleration in terms of t. Again, that means they're looking for an equation. And the acceleration is the first derivative of velocity and the second derivative of position. Now, I did not put units on there. So if they give you units, you must give them units back. It is unlikely that they will take points off an equation, right? But it's just a good habit to get into. Any number, any value you put in for t, you're going to get out meters per seconds out of this when I use this. Here, you're going to get meters per second squared. And again, they're not going to take off points if you don't have units on an equation, but they will every time they give you a value. So it's, again, a good habit to get into, to constantly think about units every time they give you units. So using your velocity function, calculate the time when Wile E reaches his highest point. Now, you have a parabola. You know this is a parabola. The highest point is a maximum. I don't need calculus to find the maximum, but part of the directions on the AP exam will be anytime you're expected to, you need to find a max or a min of a function, even if you have your calculator in your hand, or even if you're just using algebra, you will lose points if you do not show the calculus that you needed to use to find it. So for me, calculate the time when Wile E. Coyote reaches his highest point. There's his highest point right here. And it is when there is a horizontal tangent, and a horizontal tangent has a slope of 0. So what they're looking for is for you to take the first derivative and set it equal to 0. There will be a rubric point for this statement. Taking the first derivative and setting it equal to 0. I don't need to see any work after that. This is just going to be 24, right? I'm going to subtract 24 and divide by -9.8, so it's going to be positive. And I used my calculator with that, and I got approximately 2.5. I got 2.449 seconds. This is a time. Use the appropriate units. So I calculated the time. Now they want to know how high. That is a position equation. Because remember, you've got 3 equations here. You've got position, velocity, acceleration. So always check which equation should I be plugging into. If they ask me how high, I need to go to the position equation and I need to plug in the value that I just found in the previous problem. Now let's pretend you made a mistake here. If you made a mistake here and imported an incorrect answer in, you will still get an FT, a follow through. You will get FT on your answer as long as you don't make any other mistake. Now, if I have my calculator, I'm actually storing this value in my calculator. And in previous classes, they taught you how to store. I store it in alpha A. And then I put A here. AP expects you to maintain accuracy with your calculator when you can. So I did this and I got 29.388. This is a position. So my position units are meters. When does Wile go splat? So when is a time issue. Splat means hit the ground. So on my position graph, that's an x-intercept. Now, I don't have to use calculus to find x-intercepts on functions. That's also in the directions of your AP exam that you won't listen to. I can either use algebra, right, to find the x-intercepts, which means factor and solve, or I can use my calculator and find a zero, use my calculator to find the zero, or hello, I did find the time, right, when I found the time at the height, and because of parabola, I just have to double that, right? So 2 times the time when I was at the maximum is the time .898. Sorry, that didn't copy well. Right? Remember with a parabola, because a parabola is beautifully symmetric, right? If you found the time of the max, right? This is 0. Just double it. Right, because this parabola does hit the x-axis, right, is at 0 here. So it took from 0 to 2.5-ish seconds to get to the maximum. So it takes another 2.5 seconds to get to the other x-intercept. Or again, you could just use the quadratic formula or use your calculator to find, as long as you know you were finding an x-intercept and you communicate, set up the math equation, whatever it is, and get the answer. All right, next goes to the questions that you were asked that we talked about in the previous content video. When is Wile speeding up? When is the speed increasing? When is the speed going down? And what does AP expect for you from an explanation? So remember yesterday we talked about speeding up is when your velocity and acceleration have the same sign. Slowing down is when velocity and acceleration have opposite signs, working against one another. That's really the explanation. That's all they really want from you. Right? So, and again, I know what this parabola looks like. Without calculus, I know that I'm increasing from, right? Increasing, but my slope values are getting lower on the first part of the parabola. So from time 0 to time A, and I defined A, by the way. I defined A to be 2.449, so I can just keep writing A. Velocity and acceleration have opposite signs, therefore slowing down. But over here, slopes are negative and getting more and more negative. The slope values are decreasing and the values of the slopes themselves are negative. So from A to 4.898, speeding up. Because velocity and acceleration have the same sign. That's all they need for the explanation, right? Talk about the signs of velocity and acceleration. Are they the same or are they opposite? Speeding up, slowing down. The signs on the slopes either match whether the slope values are going up or down or not. Now be careful with the next question. When, so again, that's a time question. When does Wile reach his maximum speed? And remember, speed is always a positive number. So maximum speed. Speed, remember, comes from velocity. But velocity, remember, comes from slopes. So when are the absolute value of the slopes the highest? So this question really says, when are the absolute value of the slopes the highest? All right, so I'm going to draw my graph again a little bit larger. So let's draw Wile E. Coyote's graph. At time 0, he's on the ground, steps on a landmine, is hurled up from the surface of the earth, and then is going to come back down. Splat. Now remember, he's not following that path, right? He's going straight up and then back down. Splat. This is just because time is spread out, right? Time 0, time 4.8-ish. There's the symmetry. We found out this was about 2.5, right? Approximately. When do you have the highest slopes? Well, it's certainly not at the maximum. That slope is a slope of 0. It's not just to the left or just to the right of that horizontal tangent either. Where is it? Right when he leaves the ground, right? Just as he has the explosion, that's when his maximum speed is on that end. And then where else? Right when he lands, right? So that's what they want you to say. When the absolute value of the slopes are highest is your explanation, and then your approximation is when it is. Just after time equals 0 and just before time equals 4.898. And you don't have to say right before they get that. Okay. More important that you understand what each one of these questions is asking you to do. So here is an activity that asks you to graph each one of these. Graph the position graph, right? The position equation. So the position time equation. Remember that was, right? What was that? I forget what the constant was. 24. 24 minus 9.8t. no, it's not, 24t minus 4.9t squared. That's supposed to be symmetric. And again, this is about 4.9, this is about 2.5, and this is 0. And this is height in meters, and this is time in seconds. Each one of these horizontal axes has seconds, but the vertical axes will change. This is meters per second, and this is meters per second squared. So remember the VT graph, the velocity time graph, was linear because the original was quadratic. So velocity was 24 minus 9.8t. Where there was a horizontal tangent on the original, the derivative has an x-intercept. Where the original is increasing, the derivative is above the x-axis. Where the original is decreasing, the original is below the x-axis. Here, right, what is the acceleration? The acceleration is constant on Earth, and in meters per second, it is negative 9.8. The red graph has a constant slope that is negative, so its derivative graph is constantly at that slope value. Since the derivative graph is always decreasing, its derivative is always negative. So number 11 is practice. Describe the relationship between signs and the values of the graph. So here's now, AP would be more specific, but this is what I'm asking, what I'm hinting at. Just to kind of what I was saying, the relationship between the signs. So S of t, when S of t is increasing, when S of t is decreasing, what's happening? When S of t is increasing, velocity is positive, velocity is negative. When velocity is decreasing, acceleration is negative. Since acceleration was always negative, the times when velocity is positive but acceleration is negative is when Wile E is slowing down because you have velocity positive, acceleration negative. So from 0 to 2.5, Wile E Coyote is slowing down. But when velocity is negative and acceleration is always negative, Wile E Coyote is speeding up because velocity, going faster till he hits the ground, because velocity is the same sign, has the same sign as acceleration. Working together, working against one another. Slowing down, speeding up. Okay, so that's the kind of thing that AP is going to ask you to explain. No full sentences, no paragraphs, no thesis statement, just clearly and succinctly. So the next part here, just this problem is just a repeat. You can tell this one is, I can already tell this is not on Earth, and I'll tell you why I know it's not on Earth. See his face? He's like, what's going on? Firstly, please pay attention to your labels. Every time in a prerequisite class, your teacher took off a point because you didn't write an equation. It's training for this. It is super important to this problem that you recognize I'm giving you the first derivative. I'm giving you velocity, which means you already have the first derivative. S of t is position. I don't know exactly what it is, but it certainly is, I know what degree it is. It's a fourth degree, right? Because the first derivative was the third degree. Find Wile's acceleration. If you read this problem wrong and assumed I gave you position, you would take two derivatives. But I gave you velocity. So when I'm asking you for acceleration, so acceleration is the first derivative of velocity. Velocity on Earth is not a parabolic, right? And then I'm asking you to find the speed, which is the absolute value of velocity, each time the acceleration is equal to 0. So take this equation that you just found and set it equal to 0. I'm going to factor out a 6 out of that, right? And I'm going to get t squared minus 3t plus 2 is equal to 0. So I get at time t is equal to 1 or t is equal to 2 is the time when the acceleration is 0. Should I stop the problem? I don't think so. Find the speed. So what do you need to do with those two times? Plug them into the velocity equation and take the absolute value. So you need to know what v of 1 is and what v of 2 is. And I got v of 1 to be 0. Right? So I have an instantaneous place of velocity 0. And then at 2, the velocity of 2 was, I got -1, but they wanted speed. So I need to take the absolute value of that. I didn't have to worry about taking the absolute value of 0. Okay. So I'm going to erase that because I want to draw the graph. It asks me to sketch the velocity and acceleration on the same set of axes. So what they're looking for here, they don't need a great sketch, right? So I graphed the velocity, y-intercept of -5. I used my calculator. And there is my velocity graph. Grab that cubic function. I wasn't surprised to see, right, that it looked like a snake. But when I graphed the acceleration vector, the acceleration graph on top of that, what they're looking for right? My acceleration graph had a y-intercept of 12. What they're looking for here is for you to match. Again, there's a horizontal tangent here and there's a horizontal tangent here. So my acceleration graph should have x-intercepts at those places. Okay, something like that. Doesn't have to be great. They're just looking to see, again, look at the matching behavior. Original graph is going up, derivative graph is above the x-axis. Increasing goes above the x-axis. Decreasing goes with below the x-axis. Increasing goes with above the x-axis. Okay. And you should also, again, you did find the x-intercepts here where the acceleration is 0, so you know that's 1 and that's 2, right? All right, so I also asked you to discuss the relationships between the signs and the values of the graph, but I modeled that on the previous slide, right? I modeled that here. So you practice and see if you can discuss the right amount of things. Remember, again, you're looking for relationships between the two when one graph is above and below the x-axis. What do x-intercepts mean? What do turning points mean? And what do, when velocity and acceleration have the same sign or different signs, mean? All right. And we will see you in our live session. Oh, you have to be kidding me.